Let's talk about properties of real numbers. The commutative property, and this is commutative, not commutative. It doesn't have to do with a community. It has to do with commuting. What do commuters do? Commuters drive from place to place. If somebody works 40 miles from their house, they're constantly commuting back and forth from the town they live in to the town they work in, back to the town they live in. Maybe they're a commuter student, so they drive back and forth from where they live to where they go to school. So commuters are constantly on the go, on the move. In the commutative property, that's when the order changes. The commutative property of addition says that A plus B is equal to B plus A. Everybody already knows that. Everybody knows that 2 plus 3 is the same thing as 3 plus 2. But in math, just because we can prove that 2 plus 3 is 5 and 3 plus 2 is 5, and therefore 2 plus 3 is equal to 3 plus 2, that does not of itself prove that order doesn't matter. It just proves that it doesn't matter for those two numbers. What we need is a way to show that order doesn't matter when you add any two numbers. And so that's the commutative property. This is the commutative property of addition. Here's the commutative property for multiplication. The order changes. What about the associative property? The associative properties for both addition and multiplication involve three numbers, and the order does not change. The associative property for addition says that if you add A plus B together and then add C, you'll get the same answer for A plus B plus C that you get if you add the B and the C together first and then add A to that. So if we have 2 plus 3 plus 4, that would be 5 plus 4, which is 9. If we have 2 plus 3 plus 4, so that the grouping changes. Before the 2 plus 3 were in the parentheses, now the 3 plus 4 is in the parentheses. So this would be 2 plus 3 plus 4 is 7. It's still 9. Notice the order did not change. 2 plus 3 plus 4, 2 plus 3 plus 4. So that's how you can recognize that it's the associative property, is that what's in the parentheses changes. Multiplicative property is the same. It says that A times B times C will still equal A times B times C. So that if we have 2 times 3 times 4, that should equal the same thing as 2 times 3 times 4. This side gives us 6 times 4, which is 24. This side becomes 2 times 12, also 24. Here, the A and the B were in the parentheses. On the right, the B and the C were in the parentheses. Now, this seems like it should be really, really simple to tell whether it's associative or commutative based on whether there's 2 numbers or 3 numbers. That's not always the case. If we had A, B in parentheses times C, equals C times AB in parentheses. At first glance, this looks like it's going to be the associative property of multiplication. But did the things in the parentheses change? AB, AB, what's in the parentheses did not change. What changed was the order of multiplying A times B times C as compared to C times A times B. These two things reversed. The order changed. Therefore, this is an example of the commutative property of multiplication, of course. What if we had AB times C equals BA times C? Did the things that were in the parentheses change? They both have an A and a B, but their order changed. Because the order changed, this is still the commutative property of multiplication. What if we had A plus B plus C equals B plus A plus C? What changed? Did the things that were in the parentheses change, or did the order change? Order changed. Again, this is the commutative property of addition. So they can get sneaky and make it look like it's one when it's actually the other. Now, if there's only two things, it can't be the associative property. What if we had 2 plus 5 plus 7 with parentheses there equals 2 plus 5 plus 7 with the parentheses here. Now, in this case, what was in the parentheses on the left? The 2 and the 5. What's in the parentheses on the right? The 5 and the 7. The things that are actually in the parentheses have changed. The order hasn't changed. It's still 2, 3, 2, 5, 7, 2, 5, 7. This one is the associative property, and this is going to be of addition. One of the most important rules to have for algebra is the distributive property. The distributive property is your bridge between addition and multiplication. It actually involves both. So it's not going to say of addition or of multiplication. Your distributive property says that if you have something multiplied by a sum or perhaps a difference, that we can either add these together first, as the parentheses would indicate, and then multiply, or we can distribute this multiplication by multiplying each of these things, which actually lets us do away with the parentheses. And in algebra, frequently we're in a situation where we're not able to add these two things. For instance, if I had 3 times x plus 2, you can't add an x and a 2 together. How are you going to do that? So there's no way to do what's in the parentheses. The only thing that allows us to continue is this distributive property, which says that we can multiply the 3 times the x, which would just be written as 3x. And then we can multiply the 3 times the 2, which would be 6. Or if this is a difference, let's say we had 5 times x plus y minus 5. we can distribute that all the way across all three of these. It would be 5 times x plus 5 times y, and a positive times a negative would be a negative. 5 times 5 is 25. What if we had x times y plus z equals y plus z x? Is this an example of the distributive property? Not as written. What changed? Well, the things that are in the parentheses did not change. It's an x, y plus z and a y plus z. What changed was the order of the x and the parentheses. Since order changed, this is a commutative property of the things that change their order were the things that are multiplied. What if it had x times y plus z equals x times z plus y? What changed? X is in the same place. Same things are in the same parentheses together. What changed was the order of the addition. So because it's order, because stuff moved, this is commutative property. The things that moved are added. So it's the commutative property of addition. So while we're at it, let's go ahead and throw in a little bit about inverse properties and identity properties. The inverse property, and this can be of addition. It says that A plus a negative A is equal to 0. That's for addition. That's the inverse of addition. Or the inverse property of multiplication says that A times 1 over A, which would equal A over A, of course, is equal to 1. So that's the inverse property for multiplication. It says that if you add opposites, A and negative A are opposites. Little vocabulary here. When you add opposites, you get 0. When you multiply reciprocals, when you put 1 over that, or when you flip a fraction over from, say, 2/3 to 3/2, these are called reciprocals. When you add opposites, you get 0. When you multiply reciprocals, you get 1. The identity property says that if you add 0, the identity property of addition says that some number added to 0 does not change. And the identity property of multiplication says that if you multiply times 1, it doesn't change. So these are two other properties that might be brought up that you need to be aware of. They're not that hard. The only hard thing about it is that this is stuff that you've always known for a long, long time. And now all of a sudden they have to go and make algebra and give it a name. You know how it is. We got to complicate everything. Can't leave it in the easier soft version. So play with these, just treat it like a puzzle, and pretty soon you'll catch on to it. It's not hard.